Thank you for coming. Thank you for staying to the end. I'm really glad to be the last presenter because there's no one behind me, and that means that I can keep talking until you all get bored and go home. So we're going to talk about scaling your Rails app code base with C.B.R.A, or component-based Rails architecture. Before I get into that, I want to do a quick introduction. My name is Ben Klang. I'm based out of Atlanta. I work for a company called Power Home Remodeling, which is actually based out of Philadelphia. We're a nationwide home remodeler. We do really cool stuff like windows and siding and doors and roofing, kind of not the typical thing you think of when you think of a tech company, but I promise we actually really do a lot of pretty cool tech stuff. We're actually just getting into solar, which is particularly exciting because it's this really neat intersection between technology and green products. So I'm really excited about where that's going. But more about my background is I've been working with Ruby for about 10 years, and I've been doing open source for 20. My day job today is a little bit less about hands-on code, but working with some pretty awesome people. We have, within the company, we have about 2,800 end users who use our app every day. And the app itself processes, it's a 10-year-old app. There are 59 people within the technology department spread across North and South America, and then a couple in the Philippines. And so this story today is really, it's their story. They're the heroes of this story. These are their ideas. I'm really just here representing them because they're the ones that came up with all this stuff and made it work. So I want to introduce you to our app. This is our app. We call it Nitro. Nitro does everything within our company. So from the very beginning of the entire process where a homeowner expresses interest in our products, we set an appointment with them, we schedule that appointment, we figure out which remodeling consultant is going to actually go on that appointment, we will confirm with the homeowner that they're going to be home. We will actually make sure that we tell the remodeling consultant to go out there. They'll do the entire sales process on an iPad. We collect digital signatures. We're dockless. We do this really cool thing where we can take 3D pictures of the roofing, so we don't have to actually get up on the roof with a tape measure because that has a whole bunch of safety issues. All the way to the back-end stuff, things like taking care of paid time off, taking care of the ticketing system that the help desk uses. So as you can imagine, this app is big. It does a lot of things. It was first launched in 2007, so just coming up on 10 years. It runs $500 million a year in revenue through the business. Literally every single transaction the business does goes through this app. There are approximately 773 active record models. I say approximately because I did that yesterday. There are 401 main menu items, at least the ones that I can see, based on my permissions. There are probably more than that in the app itself. And just under 500,000 lines of code. So I'm not saying this is the biggest Rails app ever. It certainly isn't. But it's significant, and it's starting, the weight of it is starting to show. So our team has one mission, and that mission is to ship. It's to ship features, to ship bug fixes, to ship code. There are things that get in the way of shipping, though, and that's the villain of this story. It's time. We're constantly fighting time, trying to get our features and our bug fixes out to users as quickly as possible. The villain has some lackeys that we're going to talk about: process drag, feature fragmentation, and scope bloat. I'll talk about each one of these things. The first is process drag. These are the things that prevent us from spending time on the things we actually want to be spending time on. The big one I want to talk about today is our CI system. So we have a full continuous integration setup. When a pull request is opened, it automatically triggers a build within Jenkins. The problem is that it takes over 2 hours for the test suite to run end-to-end, which is really painful. By itself, it's bad enough that you have to wait 2 hours between iterations to get feedback on your tests. But even worse is if, let's say you get everything done, you get you get a pass from your test suite, you get a sign-off from QA, and you get a code review done, and then somebody else pushes a change that has a merge conflict. Now you have to start that whole process all over again. This is kind of embarrassing, but in the last 2 weeks, I have actually set an alarm to wake up at 3 a.m. when the test run was complete so I could hit the merge button to get it out to production. It's terrible. Nobody wants to live like that. And this is what we end up looking like, trying to wait for our builds to finish. The next is feature fragmentation. This is the UI that we want to have for our users when they're looking to pick another person out of the system. This is a type-ahead search. You can see I've typed Brianna's name, and it auto-completed based on the word that matched. It's great because it gives me a picture of Brianna. It tells me which territory she's in, which department she's in, and even her title. And that's important because in a company, even with 2,800 people, we have 3 Greg Bennett's. So knowing which Greg Bennett you want is pretty important. The problem is we don't have one user picker. We have like 7. We have one that looks like this, which really doesn't give me much more than the name, but at least I have type ahead. We have this one, which gives me type ahead and the territory and the department, but not the title. We have this one I particularly love. It's just a long select box. We have this one, which says the name starts with, but it's not clear if that's the first or last name. And then we have this one, which you can choose the starts with for the first or last name. Those are all the different ways just to pick a user. This is a problem. This is what our users look like, trying to figure that out. And then we have scope bloat. So let's imagine you're a developer, you pick up a story to implement some feature, and you start with the logical starting point, you start with the controller. You dig into the controller, you find the method you want, and then you realize, well, it's got a couple models that it's connected to, and that's fine. But one of those models has callbacks, which creates instances of other models. Now we've got 2 other in scope. And then, of course, we get down to the view, but that view has partials, actually a couple partials. And this isn't even counting things like helper classes or service classes or presenters. Just to implement this one feature, you might have to have a dozen different files loaded into your head. Right? This is a lot. And that's when developers' heads go like this. So that's too much, right? The end result of those 3 things is our development process feels stuck. We get stuck in mud with all the overhead of just trying to build the code to ship it. So how do we get out of this mess? So the team got together knowing these challenges and started to think about what are the different ways we can address these problems? What if we did some things to fix it? One of the first things we had is, what if we built a test pyramid? This idea that you can have high-level tests, functional tests, which ensure the overall behavior of the system. And you have relatively few of those because they're slow. And then at the base, you have a lot of very specific model-specific tests that test all your different validations, right? There are relatively many of them, but they're relatively cheaper, so you can get away with that. It's a great idea, and I actually do recommend you do this, but it's a massive effort. We have a test suite that's many thousands of specs, right, of instances. And even if we were to do this and be successful, it really only addresses the tests. It doesn't address any of the other issues like how much code you have to load into your head. So we decided that's not really going to be the solution. Another suggestion was, what if we mock the database? Well, the problem with mocking the database is it hides a whole bunch of behavior that we really rely on, things like foreign keys and triggers and implicit sorts. And at the end of the day, the database is a pretty critical part of our application's behavior. And ultimately, we value that correctness over the speed, even in the case of slowing down our development process. So mocking the database isn't really a solution either. What if we dry our app? What if we take all of these different pieces and start to extract them to presenters, to models? So we have clearer boundaries between all of these different components. I think that makes sense, right? We could do that, and we should do that. But the problem is that it's really hard to enforce that. Already, our application helper is kind of a dumping ground of miscellaneous things that get used in multiple places. And it's really difficult to model the dependencies between things. You can say that this model depends on that other model, but how do you know that when you make a change in one model, you're not going to break something upstream of it? From a tool standpoint, it's basically impossible to enforce those boundaries. There's no clear way to map out the dependency graph. So simply drying it isn't really going to solve our problem. It's the right thought, but not the right mechanism. How about microservices? Anyone here a fan of microservices? Wow, just like 2 of you? That's cool. I'm actually not a big fan yet. But I say that because microservices offer a lot of the things that we really do want out of this. Clear boundaries between services, the ability to understand how they relate by a documented API, a promise, if you will. Microservices have a lot that is really appealing, but they have one really significant drawback, which is that you now introduce an entirely new failure mode into your application. Things that couldn't effectively fail before now may because of a glitch in the network. Then you have a bunch of other problems, like the tools for analyzing performance are really immature. They don't understand the relationship between all the services. Monitoring and high availability concerns become much more difficult. And you have to coordinate the deploy of multiple applications. Rather than shipping a single change relatively atomically, you've got to roll out this change to provider A before the consumer B can use it. That's a lot of work for our DevOps team as well as developers. So microservices alone aren't really the answer. Again, a good idea, but not everything we needed. We need something that's a little bit in between all of these. So we started thinking about, what if our app was actually comprised of a bunch of different gems? Well, this is good. This gives us clear boundaries of responsibility. We know that this piece of the app depends on that piece of the app. We can build an understandable dependency graph. It'll also help reduce merge conflicts because hopefully changes can be contained within one piece of the application. Critical for our overhead, it allows us to do selective testing. Rather than be too concerned about testing everything for a pull request, we can say, well, we only changed code in this particular part of the app. Let's only run those tests. And especially gives us an automated way to know what needs to be tested. If you think about it, that gives us this ability to create kind of an application framework. If Rails is a framework for building web applications, then we're building a Nitro framework, a level above that, which is a framework for building Nitro. It turns out that these ideas aren't particularly new. In fact, a guy named Stefan Hagemann has talked about this since at least 2013 with an idea called CBRA, Component-Based Rails Architecture, and the book that he wrote, Component-Based Rails Applications. This was kind of the aha. This was starting to make sense. How can we assemble our app in a way that solves these problems? So let me explain a little bit more about how CBRA works. Conceptually, this is what most Rails apps look like, right? You've got Rails underneath, and then that block of code on top is your monolith. That's all the code that you've written to affect your application. Now, in reality, there's more to your app than just your code in Rails, right? There are a whole bunch of gems, third-party pieces of software that you have bundled into your application. That makes sense. This is nice because now we can draw a line. Above this line is your code. This is the code that you are building and delivering in-house. Below this line is everybody else's code, code that you depend on. The idea behind CBRA is to take your code, break little pieces of it off into gems, private gems that stay in your repo that you are still responsible for, and then require them back into your application. So how might we go about doing this? Well, first of all, we're going to start small. Within any application, there are lots of pieces of functionality that probably lend themselves to being extracted. One really obvious place for us to start were third-party client libraries. So for example, we have two vendor partners of ours called Green Sky and Wells Fargo, and we interact with them at an API level to submit things like loan applications. The act of submitting a loan application to one of these lending partners really has nothing to do with our business logic. It's purely a client library. So that made it really easy to extract. And those were some of the first gems that we did, in fact, extract out. Now, you'll notice these are still private. They're in a separate repo on GitHub, but they're otherwise normal gems, just like you get from Ruby gems, and we put them in our gem file. We also found that there were another class of things we did, which was adding functionality to existing open source. So for example, the consent on the top right there, that's an extension we made to can, essentially a DSL, because we use can quite heavily and somewhat in ways that weren't the design philosophy of can. Regardless, we extended the library with a DSL to make working with it much easier. So that became its own gem. We also pulled out Paperclip. If you're familiar with Paperclip, it's kind of similar to Carrier Wave. It's a way to attach files to models. We were transitioning from storing all those files locally, or rather on NFS, to an object storage array. And we needed a way to know if the file had not been moved, go look at local disk, and if the file had been moved, go look at object storage. So we wrote this kind of shim layer that sits in between Paperclip and it'll auto-select which one is which. Again, both of those things are necessary pieces of our application, but don't contain any business logic whatsoever. So we extracted those, and actually those we made open source. So this is another great way to find open source value that you can release. If your company is interested in releasing open source, as we are, this is a good way to do it. So that's a start, right? You can find lots of small things to pull out. But still, the meat of your application is all of your business logic. And this is the much more interesting part, I think. Your typical Rails app has lots of models, lots of controllers, lots of views. It also has a gem file and some routes, and some other things, tests and whatnot. But mostly we'll focus on the functional parts. If you think about your application this way, you can probably start to break it into logical pieces. Maybe there's a piece for finance. Maybe there's a piece for the sales process. If you can draw a line and kind of pull those apart, maybe there's a Rails engine that can be built from that. So to get to that point, you need to add a gem file. You've extracted the models, the controllers, the views, and the specs that are relevant to this subset of your app. Now you can figure out what that part of the app depends on. And it won't be everything that your main app depends on. If you have models that attach files, you need to put in Paperclip. But you might not need you might not need can if you're not using permissions in that part of the app. Then you'll add back in a routes file, and you'll notice that this is starting to look a lot like a mini Rails app because that's exactly what it is. A Rails engine is basically just a Rails app that gets mounted inside another Rails app. This gives us a tremendous benefit because what we can do now is take our monolith, our umbrella application that contains all this code, start to break it into smaller pieces, and then link those by expressing dependencies between them. So in our umbrella application, there's a gem file that lists all of the components that we've pulled out and says, this is what I depend on. And then each of those components have a list of all of their dependencies, which, by the way, can be each other. Now, you have to be careful not to create a cyclical graph, right? And we have some rules that we use internally to help prevent that. But as long as you can have a single direction graph, then what you can do is you can say, if I have this base layer, which maybe it contains my user model as one engine, and I have another one that implements the sales process, and another one that implements something else. If I make a change in the user model, I know I need to run the tests for everything that depends on it. But if I make a change in something that's a higher level, I only have to run those tests. Now I'm saving a lot of time. I'm also saving the complexity in my head as a developer. I'm not thinking about all of the pieces below. Generally, when you're running your test suite, you're not running the Rails test suite. You can assume that the Rails test suite is passing. At least you hope it is. Same with all of your gem dependencies. You can start to not worry about these pieces you pulled out. So what does this actually look like? This is a screenshot of the file structure of our application. And you'll notice the first part, we're calling it the umbrella. And it really doesn't contain very much. It is still a Rails app. You can see it still has an app directory, a config directory, DB, specs, that kind of thing. But it has this component subdirectory. Inside that are all of the things we've extracted. I want to point out one that I don't think is on the screen. We call it the transitional component. And what we did is we took all of the business logic that wasn't yet separated into smaller components and kind of shoved it into that. That gives us the ability to have everything else depend on it. And I'll show you more in a second what that looks like. But by pulling that out, we now have a component that we can start extracting pieces from and linking it back in. Now, the last piece of the component is the engine itself. And again, you can see it has an app directory. It has config, it has DB, it has a lib directory, spec, all of the normal things you would expect to find in a Rails app because that's exactly what it is. And it's important to remember that because by being its own Rails app, it also has the independence of being tested as a Rails app. And we can run those test suites independently from the umbrella application. The other thing that's kind of neat is your components don't necessarily have to be Rails engines. I'm not going to go into too much detail on this because honestly it's not an area I spend a lot of time with. But some of our components, especially the parts of the app that are UI heavy, are written in React. So we can extract those, as we call them UI components. Those actually do have tests. They're JavaScript tests. Previously, CI wasn't terribly smart. If you went and changed a JavaScript file, it would go run all the Ruby tests. Kind of a waste. By extracting these to a separate component just for JavaScript, again, we can determine that only this piece of the app has changed and only run those tests. So what does this actually look like? This is okay. Nobody freak out. It looks like a hairball because an artist didn't draw this, a computer did. But when you zoom in, you can kind of see a couple really interesting things. First of all, I talked about the transitional component. This is the center of our application. This is all of the code that we previously had that was in the umbrella. We've extracted it to here. And you can see there's a lot of arrows coming in and out of it. That's because a lot of things either depend on it or it depends on a lot of other things. This is still by weight, probably 90% of our application. It's still also the longest test to run. But as we start extracting things, this over time becomes smaller and smaller, and each individual component can be run in parallel. If we scroll a little bit to the left here, you'll see a few things. I talked earlier about the Green Sky and Wells Fargo pieces that we have extracted. There are other things that we have extracted to private components that aren't in their own repo. They're literally just a gem in a subdirectory. The ones I'll point out here are Apple GSX client, IceWarp client, and Nitro Pivotal Tracker. So the GSX client is, I actually don't know exactly what that is. I think it has to do with provisioning. IceWarp is our mail server. So anytime a user account is created, we go and we provision a user's mail account. That obviously can be, it's a client library fundamentally, so we can extract that to a component. And then pivotal tracker is the same. We actually have actions you can take within Nitro that will update statuses in pivotal tracker. So those make for great components. And then I talked about UI. So we have over here some UI components. What's cool about this is you can see Spaces and the Home UI, which are two major systems within Nitro, one for editing homeowner information, the other for tracking conference rooms. Those both depend on a Nitro React component. So we have a fundamental layer that provides a lot of common React functionality, which is itself a component. And then we have other pieces of the UI which depend on that. So we have dried our code by having this Nitro React base component, and we can run the test for that. And if the React component changes, then we can run the test for the Spaces and the Home UI components as well. So at the end of the day, this lets me really focus on just the feature I'm trying to build rather than all of the pieces I'm connected to. What does this actually look like? What do we gain from this? This is a screenshot of a pull request that someone ran, I think it was 2 days ago? You'll notice here that the total runtime is approximately 20 minutes. So we're down from 2 hours to 20 minutes. I can iterate 6 times in what it used to take me to get one test result. This is a game changer. This is the difference between waking up at 3 a.m. to push the merge button and actually shipping your feature and then having a nice evening. We get our results in minutes, not hours. Now, C.B.R.A. might be sounding like the best thing since sliced bread, and for us it's been tremendous. But I do want to talk about the pros and cons, because this isn't necessarily for everybody. The pros, it does help you organize your code better. It enforces you, it requires you to put things into certain boxes that make it easier to enforce rules. So it provides good structure. For us, one of the big benefits was we can now parallelize our tests. Not only can we run fewer tests, the tests that we have can be run in parallel. I wish I had put a screenshot of Jenkins in here for you, but the new Blue Ocean Jenkins UI has all the dots vertically lined up from all of our components, and all of those tests, which used to be run serially, are now running in parallel. That by itself saved us a ton of time. You can reduce the number of merge conflicts by having developers work more in sandboxed areas. And you can effectively reduce the human RAM that's required, the amount of stuff we have to keep in our head. And if you like microservices, and like I said, I think there are some value in microservices, and I think we're moving toward a microservices architecture, not in a hurry, but we're going in that direction. This is a great first step toward it, because the first microservice might just be a component that we extract and make an API. But it has cons. There is significant organizational overhead. You have to think consciously about what code belongs where, and you have to teach your team about how to organize the code that way. There is some testing complexity. When we did this, we had to make sure that every component that needed database access had its own private schema, and that our test automation was modified to create the databases so that those tests could run in parallel. What you don't want to do is have all of your components pointing at the same database, because then they'll be creating objects and stepping on each other as they run, which is no good. What this means is there are tools needed adopting. There's a bit of overhead now when we do migrations, because when we add a migration in one component, any component that depends on that one now has to be updated as well. So we had to create scripts that would say, go migrate this component and then go migrate all the other components. Which also means DB rollback is kind of a pain. So a lot of the tools you get out of the box from Rails don't really work the way you need them to anymore. We also have more overhead synchronizing our gem files. Each component has its own gem file, which means it has its own dependencies and its own version constraints. We've taken the relatively pessimistic approach that the component gems should all be locked to hard versions, to specific explicit versions. And that gives us the ability, for example, when we're upgrading Rails, we actually have to go upgrade Rails in the Umbrella app, but also all of the subcomponents. So there's some overhead to that, and we haven't totally mastered how to automate that, but we are working on it. So let's try to answer the question, should I componentize? My first question is, do you have a large monolithic app? And by large, I mean dozens or hundreds of models at least. Big enough that the problems I'm talking about, the test runtime in particular, is a good indicator of that. Do you have a large number of contributors? If you're a small team, I don't think that this would do a lot of good for you. Do you have frequent merge conflicts? It felt like every pull request we would be getting a merge conflict. This helped us a lot with that. This, though, this unbearably long CI runtimes, this was the straw that broke the camel's back, if you will. This is what really pushed us to evaluate this. And then do you find it difficult to hold all of the code in your head necessary to implement a feature? If so, perhaps componentizing will help you. When should you not componentize? I definitely do not recommend doing this greenfield. There's very little benefit to doing so. You're going to incur all of the overhead of figuring out how to break up your app before you really even understand how your app will evolve. I'm still very much in favor of starting with a monolith and when it becomes a problem, breaking it up. Do you have a small team? Again, because of the organizational overhead and the education, the benefits on a small team are much less than that of a big team. Do you have a manageable and single-purpose code base already? As I kind of described, Nitro is anything but single-purpose. If you have a relatively focused app, componentization may not help you as much. And finally, is process drag not really your main concern? You may have a lot of problems in your organization, and process drag isn't one. For us, the CI thing was the thing we identified that was causing developers not to ship as quickly as they could. All right, so we're going to figure out what this constraint is, we'll solve it, and we'll move on to the next one. So I contemplated what additional reading could I leave you with, because I wanted to mostly present the concepts behind C.B.R.A. I think it's way too detailed and nuanced for me to actually give you a tech demo of this. So I started putting links together, but then I threw that out because this site really does all of that and so much more. This is Stefan Hageman's website, CBRA.info. It links to his book. It links to a lot of the research he's done. It talks about hexagonal architectures, a lot of the things that kind of contribute to this thinking. Highly recommend it. I also want to mention one other piece of open source that we have released, something called Cobra Commander. Cobra Commander is where we're, yeah, C.B.R.A., right? Couldn't help it. Cobra Commander is our collection of tools that help make working with Rails and C.B.R.A. easier. And what I mean by that is that the first piece this has is the tool that goes through, when you create a pull request and you have a branch, it will actually look at the files that changed on that branch and determine which components they map to, and then tell Jenkins what to test. So this is sort of the magic that gets you those shorter test runs. That's one big piece of it. We're also putting pieces into it to help with database migrations, as I explained earlier, and other things just related to dealing with components in Rails. So check that out. So that's it. I got through that quickly. Thank you all very much.